In this video, we will be discussing roots in the math module, including taking a square root, touching a little bit on why you can't do a negative square root in the math module, what alternatives you have if you want to use complex numbers, but we're not going to get too into that. Taking a cube root, or any other root, using exponentiation and this little formula we set out here, and then taking the integer square root, which is essentially the quote-unquote floor of the square root, as discussed in my previous video on rounding, doing the opposite of that, taking the quote-unquote ceiling of the square root, and then seeing if you can take the floor ceiling of any root, a cubed, or a fourth root, or a fifth root, etc. And if those words don't make any sense, don't worry, we will explain everything. But first things first, what does it mean? Let's do this explanation of roots quickly, which might be old hat to some of you, but what does it mean to take the root of a number? Well, in our last video, we talked about exponents and discussed how an exponent is just a means of multiplying the same number over and over and over again as many times as you like. So, for example, 2 squared is 2 to the power of 2, 2 times 2. 2 to the power of 4 is 2 times 2 times 2 times 2. And so that's the same thing as 2 to the power of 4. So just to show you that really quickly, 2 times 2 times 2 times 2 is 16. But if we just did 2 to the power of 4, which is 2 multiplied by itself 4 times, and as you might recall, one of the ways to do this is with these 2 asterisks. That also gives you that 16. Okay, well, taking the root of the number is just the opposite. Taking a look at this picture I quickly threw together in Microsoft Paint, you can see that if we were to write by hand, we'd be looking at kind of the nth root of x with this check mark symbol, which is actually called the radical symbol. This little n is called the index, and this number x is called the radicand. That's radicand. But don't worry about that terminology. That's just as an FYI, because we are not writing this by hand. We are going to be using Python to do it for us. But just looking at this next picture where we plug in some actual numbers here, here we're looking at the cubed of 8, 8 cubed, okay? The cubed root of 8, rather. Not 8 cubed, the cubed root of 8. And what's this asking? It's asking what number times itself 3 times will equal 8, okay? So in other words, it's asking us to kind of solve for n here. If n times n were equal to 8, right? If you were to write it out by hand, that might be one way that you would do it. And here is the answer is going to be 2, which you might know. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So so 2 cubed is 8. The cubed root of 8 is 2. Okay, and that's kind of what roots are. As an aside, I did, just to clarify, I did mention, that we're not going to be writing out this radical symbol. You actually can write it, you can print it in Python. It's not going to give you a means of doing the operation. But just to show you without going in depth into Unicode and all these things, which is not the topic of the day, the easiest way to do it is probably just to Google, Unicode, radical symbol in Unicode, copy it, and then paste it in. You can just print it, and it will print if you print it in a string, and then you run it. Whoops. And you see it does print. I've got a little extra quotation mark there. But it does print it out. That's not going to give you the operation. It's literally a string. If you did the type of this, if you printed the type of this radical symbol here, it's just going to tell you that it's a string. Yeah, see, class string. Okay, it's not like it's an operation or something. So then if you're not going to be able to use this radical symbol, then how do we use Python's math module, or math in Python in general, to find these roots, the square root, the cubed root, the nth root, right? Well, let's start with square roots. Square roots are just saying, what is that number squared equals my number, right? You'll hear it called radical. So if someone says radical 2, they're not, just saying, I'm a skateboarder, it's radical. They're saying, it's another way of saying square root of 2. So for a simple example, let's think of 4. what number times itself will give you 4. And how do we do that in Python? Well, we're going to use the math module. And if you've seen my previous videos, you know that to use the math module, easy peasy, you just have to type import math and you've done it, okay? And so then what do you want to do when you're about to use a function in the math module? Well, you type math, and that shows you want to use the math module. Then this dot to show you want to use a function in the math module. And then here we're going to do sqrt for square root, sqrt, okay? And for square root, and our example is going to be the square root of 4. So let's print it and see what we get. And you see it's 2.0, and that makes sense. 2 times 2 equals 4. So, of course, the answer, the square root of 4, is going to be 2. But you'll notice we're actually getting a 2.0 here. And that is interesting because that means it's a float value, not an integer. And that's what that 0.0 is telling us. Even though the question that we're asking the computer has an answer, that's just a whole number, just 2. Math.sqrt is still spitting back a float value. So if you see, if we print the type of this, and see what it gives us, it's class float. So the math.sqrt is going to give us a float value, even though the answer is actually just 2. It could be represented by an integer. So let's keep that in mind for later when we talk about this integer square root, and we'll see a little difference between the isqrt versus the sqrt. But let's revisit that when we get there. Let's do one more example where we'll get a whole number out of this square root, and then we'll move on to some harder stuff. So let's just do the square root of 81. That would be 9, right? 9 times 9 equals 81. Well, let's see. Let's take out our request to give the type, and instead let's just print. So we're going to take the math.square root of 81 and then print it and see what it gives us. It gives us that 9.0. 9 is a float value. Okay, but there are a lot of numbers that don't have a clean whole square root, right? Like 2. What's the square root of 2? It's one of these famous irrational numbers. It just goes on, it doesn't stop or repeat. And in ancient times, they devised a number of ways to come up with an approximation of the number by hand, but now we have computers to do that work for us. And like with pi or tau or e, which we discussed in my earlier video on constants, for radical 2, we don't want our computer calculating the square root of 2 for the rest of time, right? It would never do anything else. So instead, just like with a calculator, it's just going to give us an approximation. And let's see what happens when instead of the square root of 81, we ask our computer, what's the square root of 2? And it gives us this 1.4 and change, which is the computer's approximation of the square root of 2. And if you're going to use radical 2 a lot, you can always set it as a variable. You can certainly do that. So if we, I'm just going to use x. It can be, you can label it whatever you want. But if we do math.square root of 2, right, and then instead of this, if we just printed x, okay, so you see what I'm doing here? I'm setting this variable x to be the math dot square root of 2. So in other words, hey, what's the math module's approximation of the square root of 2, which we know is going to give us this? Store it inside this value x, and save it for later. Okay, and then print this value x, where we stored the square root of 2. Okay, good to go. And so there it is. And so one more thing with square roots. If you go back to my example of what's the square root of 4, so let's get rid of this, and let's print math dot square root of 4. Okay, and you remember that the answer that it gives you is this 2.0. Well, okay, that's true. The square root of 4 is 2. 2 times 2 certainly does give you 4, but isn't it also true that negative 2 times negative 2 will give you 4? Right? Isn't it true that negative 2 times itself also gives you a positive 4? And more generally speaking, we can say that a negative number times a negative number gives you a positive number, And so we can say that a negative number times itself is also the answer to, a square root question, right? And so doesn't this also have two answers? So first, I think it bears some quick explanation of why a negative number times a negative number will always equal a positive number, and then we'll discuss what this means and the implication of this for square roots. So if you're already familiar with this negative times a negative equals a positive issue, it was covered in your math class years ago, and you don't want to hear me get into it, just go ahead and skip ahead a minute or two, because I'm just going to go into it quickly. But for those of you still with us, to see why we're getting a positive number when we multiply these two negative numbers, let's look at a number line. And I already wrote one out, so let's just look at one. I'm just going to paste one in. So remember, everything to the left is trending towards negative infinity, and everything to the right is trending towards positive infinity. Well, we can actually think of this in terms of walking to the left or walking to the right. And if we take as an example 2 times 4, well, if we want to do 2 times 4, that's 8. You can think of it as I'm walking to the right 2 miles an hour, right? It's positive 2 miles an hour to the right for 4 hours, positive 4. Then I'm going to go 8 miles, okay? And so 2 times 4 is 8. And similarly, if I'm walking to the left, towards the negative, I'm walking to the left 2 miles, so that's negative 2 for 4 hours, which is a positive 4. Well, my motion's to the left, that's negative 2 multiplied by a positive number of miles per hour, that's positive 4. Negative 2 times positive 4 lands me at negative 8, because I'm moving in this direction. So you see how the negative times a positive actually gives me a negative. And so think about what would happen if both of these values were negative. I'd be moonwalking, right? I'd be facing to the left. I'm starting with a negative number, negative 2 miles an hour, and then I go a negative 4 miles an hour. At that rate, I'm facing to the left and I'm propelling myself backwards. I'm moonwalking all the way to positive 8. And so that's why negative 2 times negative 4 gives you positive 8. And what are the implications here for square roots? Well, a negative 2 times a negative 2, as we saw, gives you this positive 4. And that's important to know, but it's equally important to know that the math dot square root is going to give you the positive square root of a number. It's not going to give you this negative number, this negative 2 or whatever the case may be, that's also technically speaking an answer to your question. It's only going to give you the positive one. So just remember, math.sqrt, drilling down into what are we really asking the computer to do for us, we're asking it to give us what positive number we can multiply by itself to get our radicand, to get the number that we're asking it about. And so that's just one key thing to remember with square roots and how Python treats them. Can we get this negative value of our square root? Well, sure. Since the answer is just going to be the negative of what we get with the math.square root, we can just do negative math.square root of 4, right? And that'll say, what's this really asking? It's saying, what's the square root of 4? And then negate it, and that is going to give us let's import math and try that one more time. Negative math.square root of 4 is going to give us this negative 2, right? So it works fine. Okay. What about the square root of a negative number? So for example, math.square root of negative 4. Well, when you try this just with this math module to take the square root of a negative number, you're going to get an error message. Math domain error, value error, math domain error. And that makes some sense. As we saw earlier, a negative times a negative equals a positive for those reasons we discussed earlier. And so if a negative times a negative equals a positive, then what times itself is going to give you -4. Well, it can't be a positive number. Positive number times a positive number is going to be positive. And it can't be a negative number because a negative number times itself is going to be positive. So you can't have a real number that gives you this answer. You'll probably remember from math class that the square root of -4 does have an answer in mathematics. It's what's called a complex number. And so let me just show you. It's a complex number. It uses what's called the imaginary number. And I will quickly show you how to do that, though it's not really the topic of the day, because you can do complex numbers in Python using this module called cmath. And so cmath, C stands for complex, and perhaps topic for another day, but just to show you quickly, cmath.sqrt of -4, and you see it gives you this complex number. The Python actually uses J instead of I, which we discussed at not at length, but we discussed a little bit in one of my previous videos, I believe the one on exponents. But suffice to say, this J is really what you might have learned in math classes. Some disciplines like electrical engineering use J. It's what Python uses. But so this is really 2 times the imaginary number. So it does work for you, but let's just move right along. What about taking the nth root of something? Going back to our picture of this cubed root of 8, what if we wanted to take the cubed root of 8 in Python instead of the square root? Well, square root, we have this math.sqrt. It's really nice. It's this one function in the math module. There's no similar equivalent thing for the cubed root or the fourth root or the nth root, the going on and on, right? Of this n, you can only do it if this n is 2 and you have that square root, but the cubed or going on and on to infinity, like the 500th root of something, there's no one, nice function that you can use in the math module or just in Python generally that has it. But the good news is that we can use some arithmetic to get the result that we want, and that is by relying on the principle that the nth root of x is equal to x to the power of 1 over n, and that's a big mouthful, so let's show it to you in a picture. And so as you can see in this image, the cubed root of 8 is actually equal to 8 to the 1 over 3, to the 1/3. Let's just try it. Remember, we discussed exponents at length in my previous video on exponents. There's lots of different ways to raise something to the power of something else in Python, but just so we're not repeating that video for purposes of this video, let's just use the 2 asterisks. See the previous video for like pow, math.pow, all these things, right? But instead, let's just use these 2 asterisks. 8 * 1 over 3. Okay, so that gives you 2.0, which, as we saw earlier, is the cubed root of 8. So that's great. Let's try it with one more value, though, just to show you. And let's do it with 27. So 27 to the power of 1 over 3. What's this asking? It's asking you what's the cubed root of 27. And it's 3. And, of course, 3 times 3 is 9. 9 times 3 is 27. The cubed root of 27 is 3. Okay, so we're good to go with this formula, and with a caveat that I'll discuss later with negative numbers. But just to note, we can use the same principle to find any nth root. But I'll warn you, there's some limitations based on issues with calculating float values that lead to some wonky results that you might not expect. So if we have 7 to the power of 9, for example, it gives us this number, 40 million and change. This nice number. And so just the same, say you wanted to take the 9th root of that number. So let's copy paste it and then raise it to the power of 1 over 9. And that should give you 7, right? Because we just took it, 7 to the power of 9. So what's the 9th root? Surely it must be 7, right? Well, no, it gives you the 6.999 repeating. And I know some of you out there who are really mathy are probably saying, hey, 0.99 repeating equals 1, and that's true. When 0.9999 stretches out to infinity, it actually, it's not like it's close to 1 or it represents 1 or it approximates 1. It actually equals 1. And that's a mathematically proven concept, which is fascinating. And if you have no clue what I'm talking about, Google it because it's really interesting. But that's not what we're hoping to see here. We don't want to see 6.999 repeating. We want to see our 7.0. What's happening? Well, there are limitations in arithmetic with these float values. It's not a Python thing, it's a computer thing. So for example, 0.1 plus 0.2, we all know, humans all know that 0.1 plus 0.2 is 0.3, but what's the computer going to give back to us? It gives us back this, 0.3 with some garbage at the end. And why? Well, it's not the subject of this video. I'll put a link in the description to a write-up of what's going on here. Suffice to say that the 0.1 you're seeing on the screen is not really a value of 0.1. Python only prints it as an approximation of the true value that it's storing when you give the 0.1, and that's actually just the nearest representable, the value it's stored. It's just the nearest representable binary fraction to 1/10 that the computer can do. There's just some limits with how this computing works. Like I said, it's a topic you can go really in depth with, which is not the subject of today's video, so I'll just put a link in the description for more info. But what is relevant for us is we just said, hey, I don't want this 6.99999. I want a 7. Well, really, I want a 7.0. And if you want your 7.0, one thing you can do is just have Python, round the result. So if you just wanted a 7, you can round it and to the nearest integer, or I'll show you how to do a float as well. But the result you're going to get from the computer is going to be extremely close to the 7. It's just a little off, and so what you can do is you can just round it to bring it over the finish line and get the result that you want. If you do round of, good, I still have it in my clipboard, this 40 million and change to the power of 1/9. And that gives you your 7. And so that is to say, take the 9th root of this number, and then round that to the nearest integer, and that gives you this integer 7. Remember, that's not exactly what the math.sqrt gave you. It gave you a float, not an integer. So as mentioned, if you really want to get that float value, remember from our previous video on rounding, you can do round to a float value by feeding in the number of digits you want by adding this second argument to the end. So, and I won't go too in depth in this because there's a whole video on it. But if you do this expression and then comma and then this particular example doesn't really matter which second number you put in here because it's going to be a 0.0 anyway, but just put a 0 at the end and you see 7.0, and that gives you what you would have gotten if the math.sqrt function hadn't had these issues with the floating point arithmetic that all computers and all computer languages have. It's not just a Python thing. Okay, so just to go recap what's going on here, back to our nth root of x picture. We have the number we're taking the root of, which is the 40 million and change, and that's the x. The root we're taking, this index, right, the 9, that's the 9 in the 1/9. And then we're taking x, to the power of 1/9. So we're taking the 9th root of x. And then we're rounding it to smooth out these limitations from floating point arithmetic and to get the answer we're expecting. And we're throwing in another, 0 here to get to be 0.0 at the end so that it's a float value. And so that's exactly the answer we would have been expecting. Okay, one last thing. If we're taking the nth root of a negative number, And we're not going to talk about complex numbers again. We covered that very briefly. But I'm just talking about when we can expect to get a real number answer here, taking the nth root of a negative number. There's one thing to keep in mind, and that's order of operations. If you're taking a cubed root of a negative number, say negative 27, you expect to get the negative 3 as your answer, right? Because negative 3 times negative 3 is 9, positive 9 times 3 times negative 3 is negative 27. Just to show you, negative 3 times negative 3 times negative 3. Okay, good. So please recall, though, from my exponents video that the order of operations with exponents takes the exponent first and then does the negative. And so I'll just show you with this. If I did negative 3 star star 3, it gives me negative 27. And so you might think, okay, this is great. This is giving me all that I need. It's giving me negative 3 to the power of 3, negative 27, which is exactly what I expect based on, what just came above. Okay, but that's not really what it's doing. Remember from the previous video that what it's asking is what's 3 to the power of 3, and then negating that, which in this case is the same thing. It is going to be negative 27, but don't get too comfortable with that because it presents an issue when these two are not equivalent questions to ask the computer. Because if we try it with, for example, taking a fourth root of negative 27, if we did negative 27 to the 1/4, if we wrote it like this, negative 27 to the power of 1/4, it gives you this number. Okay, it gives you some number, but think about it. How could it give you this number? It's not possible. This isn't the fourth root. It can't be the fourth root of negative 27 because a negative number, this number, times itself 4 times would have to give you a positive number just by its nature. It's a negative times a negative times a negative times a negative. It has to give you a positive number. It can't be the fourth root of negative 27. This is just wrong. Okay, well, then what should we actually be getting? We should be getting some complex number, right? And, well, what's the answer? What's the reason? As mentioned, it does the exponent first and then it negates it. What it's really asking, you can think of it as like this. 27 to the power of 1/4 and then negating that, because that's how it's doing the order of the operations, exponents, and then it's seeing this as a subtraction, and that's what it's giving you. How do we fix this? You just put it in parentheses. Parentheses is first in line, and you'll be good to go, and you'll be getting that complex number that you so crave. Okay. Next thing, just to switch gears, I want to discuss integer square roots, which is a different function in the math module. So let's go back to here. We can think of integer square roots as the floor of a square root. And if you're not sure what that means, please do check out my video on rounding, which discusses finding the floor and ceiling of a number in much greater detail. But just to skim the surface of it, when we take the floor of something, we're in essence rounding it down to the nearest integer. When you take the ceiling of something, we're in essence rounding it up to the nearest integer. So if we do 8.777, if we did math.floor of like 8.777 or something, it's going to give you 8. It's going to round it down to the nearest integer versus the ceiling is math.ceil of that same number or a similar number. It's going to give you 9. It's going to kick it up to 9. And so you could also, by the way, just do int of 8.777, and that will convert it to the lower integer. It'll round it down to the nearest integer downwards. Or you can think of it as chopping off all the numbers after the decimal and just leaving you with this integer. So the math module comes with a function to find an integer square root, which is math.isqrt. isqrt. isqrt. And be careful here. On first glance, this might be confusing because there's a whole bunch of functions that start with is for is. In the math module, you have isnan, isinf, and that's asking, is this not a number? Is this an infinite number? Those are both discussed on my video on constants, but this time it's starting with an is, but it's not asking an is question. I actually presumably stands for integer, and what it's going to do is it's going to find your square root and spit out that as the rounded down integer value of that square root. So let's try it with 2. As you recall, not going to this, just doing the normal square root first. The square root of 2 is this 1.4 and change, right? What if we wanted just the rounded down integer? We don't want some float value. We just want this integer rounded down, which sometimes you might want depending on what you're up to. And so if we do this, it will actually give you the 1, which is the floor of your square root. You can think of it. And so that's math.isqrt2, which just gives us the 1. Okay, you might already see a difference here between math.square root and math.isquare root. If we do math.sqrt of a number, even when the result is just a whole number, like we saw with math.sqrt4, the square root of 4, it gives you this float value, 2.0. But the isqrt, as it is the integer square root, it will give you an integer. So math.isqrt 4, as you see, it gives you this 2. No 0.0 at the end, and just to show you, we'll take its type, and it is class integer. Okay. So depending on what you're doing, if you're looking for an integer, the isqrt could be the right choice for you, regardless of whether you're expecting it a whole number. If you don't want that float, you want the integer for whatever reason, depending on what you're doing, you might want to use this isqrt, regardless of whether you need to find a floor or if you just have a whole number that you're dealing with. Okay, now recall from my rounding video and what I just mentioned earlier, there's the floor, which rounds you down to the nearest integer. There's also the ceiling, which rounds you up to the nearest integer. So for example, we did one earlier, but just to show you, math.ceil of 2.1, gives you 3. It rounds it up to the nearest integer. How do you take an integer square root function and give you the ceiling of your square root rather than the floor? How do you round your square root up to the nearest integer? So when we give you the square root of 2 and it gave you that 1.4 and change, and we rounded it down to 1 using the I square root, what if we wanted to round it up to 2? Again, there's no ready-made function for you, so instead you have to use a little math to get where you need to go. And what we can do is we can take the integer square root of x minus 1, okay, take that, and then add 1 to that. So I'll show you. If we take 1 plus, well, actually, rather than typing it out again, I'll show you because I actually have it up here in my heading. If we take 1 plus math dot integer square root of x minus 1, okay, that will actually give us the ceiling of the square root. And I didn't come up with that. That's in the documentation in the math module documentation. They actually suggest this. So I'll, as always, the link to the documentation will be in the description. So let's just show you really quickly how this works. And let's just do it with, math.isqrt. Let's keep going with the square root of 2. And so if we were to take the integer square root of 2 minus 1, okay, would be the integer square root of 1, right? And that gives you 1. And so what we do here with this formula is add 1 to it. 1 plus math.isqrt of 2 minus 1, and that gives you 2, which you'll notice is the ceiling value of the square root of 2, right? Because remember, the square root of 2 was 1.4 and change. The ceiling of that is 2. And so 1 plus math.isqrt of 2, right? From there, minus 1, and that'll actually give you that ceiling of 2 that you're looking for. Well, let's do one more example, just with a kind of a cleaner number that just gives you a whole value 25. The square root of 25 is 5, right? Because 5 times 5 is 25. So let's do 1 plus math.isqrt of 25 minus 1. So what is this asking? It's asking the integer square root of 25 minus 1, so the integer square root of 24, and then add 1 to the whole thing. And that gives you 5 again, because remember the ceiling of an integer is still that same integer, so that makes sense. So will this work with a really big number? Okay, well, let's see. What's the square root of 100,000? Just the regular square root. You see it's like this 316 and change. So if we wanted the ceiling of this, the ceiling of the square root of 100,000, the answer we're looking for is 317. So if we do 1, well, before we add 1, let's just show you math.isqrt of 100,000 minus 1. Okay, so that's, in other words, the integer square root of 99,999 is 316. And then if we were to add 1 to that, of course, it would give us the 317 we're looking for. So plus math.isqrt of 99,999, or 100,000 minus 1, and that gives you your 317. And so, as I mentioned before, this is the way that's recommended in the documentation for the math module. So check out that link in the description. But there are, other ways you can do this, I suppose. So you could take the ceiling using math.ceil that we learned about. So math.ceil of math.isqrt of 100,000. And wait a minute, that gives you 316. Ceil of, that's because I'm using the integer square root. So math.ceil of math.square root of 100,000. Okay, so yeah, they ignore this. So the ceiling of the square root. So what's this asking? It's asking what's the square root of 100,000? Take the ceiling of it, and that should give you 317, and it does. Okay, so that's one thing you can do, is you can take the square root and just find the ceiling of it. This is a more manual thing in a program. Again, everything depends on what you're doing and what you're looking for and what you want. But you can envision plugging this formula in and using it, in some kind of way where you're using it over and over again. So it just depends on what you're doing. Okay, so then moving on, that brings us to these nth roots, like cubed roots and such. If you wanted to do integer cubed roots, integer fourth roots, what can you do? Well, recall from the picture that x to the root n equals x to the power of 1 over n. So, the cubed root of 8 equals 8 to the 1/3. And so, recall from that, we can represent, for example, the cube root of 100 with 100 to the power of 1/3, and that gives you like this 4.6 and change. Well, it's the same principles as before, but this time, let's take the integer cubed root. There's a few ways you can do that. You can do the floor of the value, to get just the floor. That's math.floor of this expression, 100 power of 1/3, and that gives you 4. Okay, or you can take the truncated. You can math.trunc of 100 power of 1 over 3, and that gives you 4. Or you can also just, perhaps the most true to life, just take the integer of it, to take the integer square, or cubed root rather, take the integer of the cubed root, 100 to the power of 1/3, and that does it too. And then if you want to do the ceiling instead, of course you can certainly do so. Just use the math.ceil of 100 1/3, and that'll boost it up to the next integer. It's boosted up to 5. Remember, the actual value was this 4.6 and change. The ceiling will give you 5. And you can round it too, just for good measure. And that'll give you 5 because it was closer to 5. It was like 4.6 and change. Okay, so you can do that too. Just remember this is all the round function. Remember the caveats that we learned with the round function in the round video. And of course, with any kind of rounding, remember there are also some limitations with the floating point arithmetic, which will also be discussed in that link I'll give in the description, which goes into detail on limitations in floating point arithmetic with Python. Okay, well, that's it for today's video on roots. Thanks very much for sticking with us as we went through the explanation of the roots, the taking the square root, the nth roots, the integer square roots, ceiling of square roots, and the integer ceiling of the nth roots, sprinkled in a little bit of the complex number stuff. And I want to thank you very much for watching.